All right, now we're on to the second problem from difficulty 2. And this is going to work exactly the same way as it did in the first example. Same method, similar substitution. But notice here that in this quartic, we have y to the fourth minus 2y squared plus 1. Remember in the last example, we let y equal x squared. In this case, we have y as our primary variable in this expression, so we need to pick a different variable that we can use to substitute. So first things first, we're going to let smiley face, yes, your variables can be a smiley face, we're going to let that be y squared. So now every place I see a y squared, I'm going to replace it with the smiley face here. So rewriting my stuff, I have y to the fourth minus 2y squared plus 1, but that's going to be equal to y squared squared minus 2 times y squared plus 1. Okay, now I can carry out my substitution with smiley face. So this gives me smiley face squared minus 2 smiley face plus 1. Okay? Now we're just going to have to treat smiley face as a new variable here. You can let it be u, you can let smiley face be some weird Greek letter, you can let it be z, it really doesn't matter. I use smiley face just to show you that it doesn't matter what you call your variables. So just as before, I need two numbers that add to minus 2 that multiply to be minus 1. So let's look at the factors of 1. 1 times 1 gives us 1, but similarly, minus 1 times minus 1 gives us 1. So we look at minus 1 times minus 1, and I add those together, that's clear I get 2, or minus 2 in this case. So minus 1 times minus 1 gives us 1. Minus 1 plus minus 1 gives us minus 2. So writing out our factorization, this gives us smiley face minus 1 times smiley face minus 1. Okay, so now we're not quite done yet. Just as before, we wanted to factor this stuff with y's in it, and now we have suddenly a smiley face. So we need to replace the smiley face with what we substituted earlier, undoing what we did earlier. So every place I see a smiley face, I'm going to replace it with a y squared. So here's a smiley face, y squared, minus 1, times y squared, minus 1. Noting that these are the same exact factors here, this is the same as this, I can simplify this a little bit further by writing y squared minus 1 squared. And right there is a full factorization of the original expression up here. If you start to see the pattern of how this is starting to work out, there's a lot of steps that you can skip along the way. Like, you don't necessarily need to do a substitution to get full credit on your work, and most professors or teachers are going to accept if you just saw the pattern and then immediately basically went for the kill, trying to find two numbers that add to minus 2 and multiplied to 1. And then you factor it down to here as your next step. So substitution's only there as a helpful guide. You can go without it if you can see the pattern. So at this point, this problem is done, and we are fully factored.